Hello students, welcome to chemistry classes. So under this P block elements, today we are going to discuss this group 13 elements boron family. Group 13 elements boron family. So we know that boron family consists of boron, aluminum, gallium, indium and thallium. Boron, aluminum, gallium, indium and thallium. The boron is only non-metal present in the boron family. All other elements, aluminum, gallium, indium, thallium shows greater metallic character. The important sources or the occurrence of these elements are given below. Listen, boron is the relatively rare abundant in the earth crust, but it exists in the form of some compounds as borax, Na2B4O7, 10 molecule of water, kernite, colemanite, orthoboric acid. These are some important sources or minerals of boron, borax, kernite, colemanite, orthoboric acid. And aluminum is the third most abundant element present in the earth crust. The most abundant element present in the earth crust is the oxygen, that is 45.5% mass of earth crust accommodated by this oxygen. The next is silicon. Second most abundant element is silicon. So both are exist in the form of silicon dioxide. The third most abundant is aluminum, as in 8.3% of total mass of the earth crust is occupied by aluminum. And the sources of aluminum are bauxite, cryolite, orthoclase, mica, beryl and corundum. Bauxite, corundum is a hydrated form of this ore of aluminum. This is anhydride form of aluminum trioxide, that is called corundum. So this is the principal source of aluminum. From bauxite, aluminum can be profitably and economically extracted. Gallium, indium and thallium, so not familiar or not abundant in the earth crust. So these elements are often associated with the adjacent elements. Some of the compounds can be extracted from the nearby elements and their sources, especially the rare mineral germanite. The gallium is found in. Gallium is found in the ore called germanite. Gallium is found in the nearby metal, that is the germanium, the germanite ore. Okay, and indium and thallium are found in zinc sulfide and lead sulfide ores. Zinc blend, lead sulfide and lead sulfide galena. The abundance of these elements in the earth crust, boron, that is relatively abundant, 38%. That is among the comparing this mass by totally 13, that is 9 abundance in the earth crust, ppm, parts per million. 9 parts per million is present. Boron is relatively rare abundant. So these are some occurrence of this group number 13. Group number 13 elements. The general characteristics of group number 13. Now we are going to discuss the general characteristic properties. First of all, the electronic configuration. All these elements having NS2, NP1 as the general electronic configuration. General electronic configuration of this boron family is NS2, NP1. You remember the atomic number of boron is 5, that is 1s2, 2s2, 2p1. 1s2, that is NS2, NP1. Aluminum 3s2, 3p1. And gallium 4s2, 4p1. Indium 5s to 5p1, thallium 6s to 6p1 as the outer electronic configuration. And atomic and physical properties. The important atomic parameters and physical constant of group number 13 are discussed now. Atomic and ionic radii. Atomic and ionic radii of group number 13 elements are smaller as comparing to the correspondence of group number 2. As we comparing the size of group number 2 and group number 13, the group number 13 elements are smaller in size than alkaline earth metals. This is due to increase in nuclear charge. When we move from the group number 2 to 13, group number 2 to 13, the nuclear charge increases. So, the valence electrons are tightly held together by the nucleus. Therefore, size of an atom get reduced. And moving down the group, size of an atom increases because the electrons are enter into the new main energy levels. New main energy levels or new cells. The size of an atom get increases. And second one is ionization enthalpy. So, you remember as we move from left to right in the periodic table, ionization energy increases. I already told you from the left to right ionization energy increases because the electrons are enter into the same main energy level. The force of attraction between nucleus and the valence electron increases. So, the boron family shows higher ionization energy as comparing with the alkaline earth metals. And similarly, we are moving down the group, the ionization energy decreases. Electronegativity of group number 13 elements are more than those of group number 1 alkali metals and group number 2 alkaline earth metals. Why we are comparing this group number 13 with group number 1 and 2. So, in between the group number 3 to group number 12, the D block elements are present, and the first two periods no elements are present in the D block. So, only we are comparing the periodic properties with alkali and alkaline earth metals. So, as the general trend, this boron family shows this ionization energy and electronegativity higher than that of alkali metals and alkaline earth metals. Melting and boiling points. Melting and boiling points decreases on moving down the group. However, decrease in melting point is not regular as the boiling point. So, generally the melting and boiling points decreases, but the values are not regular because of this metallic as well as non-metallic character. Boron is non-metallic in nature. It is extremely hard and black colored solid. Boron has very strong crystalline lattice and therefore it has very high melting and boiling point. As a metal, it's a non-metallic character. Rest of the members are soft metals with low melting and high electrical conductivity. Gallium is a very low melting point, that is 303 Kelvin. Gallium 303 Kelvin, it exists as liquid at room temperature. Gallium is exists as liquid at room temperature. So, it is high, it melts in our hands in summer because of its low melting point. It is high boiling point to make the useful material for measuring high temperature. So, gallium is a liquid at normal temperature. Okay. Then boron exists as common allotropy forms under different conditions. Boron shows different allotropy forms. The last point is electropositive or metallic character. Due to high ionization enthalpies, these elements of group number 13 are less electropositive as compared to the elements of group number 2. And moving down the group, the electropositive or metallic character increases because ionization energy decreases. Boron is a non-metal while other elements are typically metals in nature. So these are some general characteristic properties of this boron family members. So we discussed the atomic and ionic radii, ionization enthalpy, electronegativity, melting and boiling point, electropositive or the metallic character. The last one is oxidation state. So I already told you the boron source, boron, aluminum, gallium, indium are the 4 element source plus 3 as the common oxidation state in most of the compounds. Thallium is the only element source, this +1 oxidation nature. And the thallium is toxic in nature. This compounds are the elementary form of toxic. The thallium is toxic in nature. This is oxidizing nature. Okay. So I conclude this topic. If you have any doubts, you may ask. Thank you.